IP address is a two parts. One is network part, another one is host part. Examples are there. So if you go to this example like this, one example is like this. It is if you know the your roll numbers, right? So my roll number is 150A, 5B, something like 04, 15B, 0402. This is my engineering roll number when I joined. It is 05, not 15. Okay. It's 2005, second year I joined. Okay. So it is a college code, right? This is my roll number. This is my roll number. And this is my branch number. This is a college code. And this is my year. Okay. This is simple to understand. So why it is divided like that? So simple. As I said, 05, A, 15, B, 04, 02. I am really remember after so many years. I'm using this example after so many years, almost like 10 years, 12 years back, I use this example. Okay. So this is a roll number. So in my classroom, everybody having this roll number, right? Means 4 is common in my classroom. Okay. 4 is common. 04 is common. Remaining is different. So it is each identification. This is my roll number. This is another person roll number. This is another person roll number. Like each number is different for a different person. But everybody is in same classroom. But so this is a common. For example, in our college, we have a CSC people, for example, 0201. So is this? This is a roll number. This is a branch code. It means both are different. 0202. This is different person, not me. So because in this one, this in this branch, it's a different person, but same college. By this one, we can understand both are same college, but both are different branches. Okay. So for example, there is a 06 A15 B0402 is my junior. How is my junior? Same college, different years, same branch, same roll number, but different year. This is how it is separated. The same way, the IP addresses are two parts. One is network, another one is a host part, network portion and the host portion. Okay, to make it in a logical network way. Okay, here is the rule. Here is the rule. The if network portion must be same, host portion is different. For example, the network portion is like a one and host portion is one. Network portion is one, host portion is two. Network portion is one, host portion is three. It is all these three devices are belongs to same network, and host identity will be different. Okay. So again, I removed some examples from there, but if I show you that one simple, if in case if I given a roll number to your batch, for example, this is a old roll number. It's I given a 24 to this 2024. Okay. So this is like a you know branch code like this kind of stuff. Okay. So it is for a which batch, which roll number, HCL or not. So if I give an identity, so we can easily identify the particular device in the specific network. Okay. Guys, once again, IP addresses are divided into network portion and host portion. So by default, the class A IP address, the first portion represent network portion and remaining represent host portion. Why it is divided into network and host portions? To control number of hosts per network. Okay, to control number of hosts per network. So we divide them into network and host portions. Okay, because already I told, so we divide an IP addresses into 5 classes. There is a several reasons to divide the IP address into classes. Okay, and these first three are unicast address, which is we are able to use it except 0 series and 127 series. We can use it from 1 to 126 from class A, and remaining is 128 to 191, 222 to, sorry, 192 to 223. All we can able to use it, all we can able to assign to a device. Of course, there is some conditions also there. Okay. If you use class A IP address, the first portion is network portion, remaining is host portions. If you use class B, the first two portions of network portions of an IP address is network portion, remaining is host portions. The first three are a network portion, remaining is host portion in class C. So how it is happen like this? You can see here it is 10 means it is a class A. See it is, this is a one IP address in a class A. This is a network portion. All remaining are host portions. All remaining are host portions. And I have another IP 10.0.2.4, 10.3.40.20, 10.100.200.20. You know, assign all these IP addresses to the 4 devices like a one, client 2, client 3, or client 4. 4 computers, 4 IP addresses are assigned, and all these can be communicate each other. How? Their network portion is same. Host portion can be different in either one or in a multiple way. For example, this is the host portion I have. I can have like this, no problem. One of the host portion is different, or many of the host portions can be different. Okay. Now it is both are not same because here it is a 0, here it is a 1. Both are same network, but both are different host IDs. Okay. So either one or multiple places host portion can be different, but network portion must be same. That is a rule. Okay. If network portion is same, so people will communicate each other. All these 4 and these 5 systems are in the same network only. Of course, this will create a conflict. So we'll give another one like a 4. Okay. So all these 9 systems are same network only. How? The network portion is same. Guys, understand in a class A, what is the network portion? What is the host portion? If devices want to communicate in the network, their network portion must be same and host must be different. Not all host portions, at least one of the host portion is different. At least one of the host portion must be different. I will add that one. At least one of the host portion must different. Okay, at least one of the host portion must different. Now we can see must be different. So it is different is here now. Like devices are in the same network can communicate each other. Means their network portion is same. Another line is the devices are in the same network means their network ID is the same. Guys, these are all important points, always useful when you are dealing with any type of network related kind of stuff. It is maybe a core networking related, cloud related, server related, Linux related, whatsoever it is. These points are always important. Okay, in any local LAN network, in one single network you are there, it means their network ID must be same, then only the devices will communicate each other. Okay, I given an example of class A and also I will give example for a class B also. For example, I have 172.16.0.2. This is my IP address. And one PC I configure like this, another PC I'm configuring like this 0.3. One portion or more portions. This is class B. The first two portions are network portions, the remaining is host portions. So there is a compulsory that is the network portion must be same, network portion must be same, host portion can be different. At least one of the host portion can be different. Okay. So both host portions are different. That kind of stuff, no problem. Like here is a 2, here is a 0, 3, 3. Okay. But no 0, 3, no 2, 0, 3. Again, should not be repeated. You should not have same IP address. Same to same IP address should not be there. But one of the portion is different. So that is good. Okay. Not it should not be same to same IP address. So you have a 5 IP addresses are configured to the devices. All these things are in the same network, so they can able to communicate each other. In case I put a 170.16.2.4, it won't communicate. Why? Because it's a 170. One of the network portion is different. In case I put a 172.17.2.5, it is also won't communicate. It's a different network. Okay. So different network means it won't communicate with our network. The same local network. And it is same goes for class C also. I took a 192.168.1.20, 192.168.2 sorry 1.21, maybe 192.168.1.42. See, only host portion is different. And network portion is three network portions in a class C, all are same. So these three systems can able to communicate each other. Any one of the network portion is different, it won't communicate. When you follow sequence is good, but there is a difference in network portion, they won't communicate. Any one of the portion is different, won't be communicated. See, won't communicate. So same examples I have written here. So there is a three PCs are connected in the network and configured an IP address like this. See this first portion of the IP address is 110. It is a class A. And see the first portion. The class A is first portion is network portion. Check it for PC2 and PC3, same network portion, and host portions is little different. Means one of the host portion is different. That is good. But network portion is in a PC3 is different from PC1 and PC2. So PC3 cannot communicate it to PC1 and PC2. Here is also same. Here is a class B network. So first two portions are network portion. Then you have to make sure that all the devices must have a first two portions are same network and remaining host portion can be different at least by one network, one host portion. At least by one host portion difference is required. Okay. In this case, PC1, PC2, PC3 can communicate each other. PC4 and PC5 are different network from PC1, PC2, PC3. This is class C network, so 200.1.2.100. The first first PC1 and PC2, the first three portions are same and host portion is different. But in the first PC3, PC4, PC5, there is somewhere in the network portions are differences are there. There are not in the PC1, PC2 network. Entire host portion should not be same in the same network. At least one of the host portion must be different. It is not required to entire host portion is same is not required. So I told that is conflict will be generated. For example, I take 170.16.2.4. Good 172.16.2.5. Good 172.16.3.6. No problem. 172.16.3.5. No problem. Because there is a post portion difference is there either this side or that side. Not as it is. But if I put another system, I configure 169.2.4. What happened? This is 2.4, this is 2.4, and the same network, but same host, same to same host. Then it is a conflict will be generated. Then it is a conflict will be generated if both network and host versions are same. Between those devices, a conflict is generated. So to avoid that one, you can use at least one of the host version is different is enough. Okay, it is not required to put a both are same kind of stuff, and it is not always required to put a both are different. So one difference is more than enough. Guys, understand what is network portion and host portion? How can you understand which is a network portion, which device can able to communicate by default network and host portion parts? So guys, what happened? Uma Devi also came. Okay, people are giving thumbs ups now. So, okay. How system can divide network and host portion? How to find a network ID? This is how system can find network portion and host. We understand from the given information if it is a class A, check it is a class A or class B or class C. If it is a class C, this is the network portion. Remaining is host portion. Check what class it is. It is a class B. These two are network portions. Remaining is host portion. This is a class C. These three are a network portion. Make sure that you have to maintain for every IP address you configured. These three are must be same. And host is different, right? We can understand, but how system can understand? How your system can understand what is the network portion and host portion. And as I said, it is default. if any changes, so like you want to define your network in different ways, so then also difference is there. How your system understand what is the network portion and what is the host portion. Okay. So your system uses subnet mask. System use a subnet mask to divide IP address into network and host portions. And it will tells network ID of that IP address based on the subnet mask. Guys, when you configure an IP address, I'm going to configure an IP address ncpa.cpl. I got an PC. Okay, go to what happens. So then go to details. Okay. Okay. So when I given an IP address to my system, the by default, the default subnet mask will be appears. So look at here. I'm giving so 120.8.9.77. Just I'm clicking on the subnet mask line. See, automatically gives a subnet mask. Okay. I'm giving 173. It's a class B IP address. Immediately it will gives the class B default subnet mask. Okay. So when you are defining an IP address, it is always better define subnet mask. You can change the subnet mask if you want it, but by default it shows some subnet mask. Okay. So what is the use of this defining subnet mask? With the help of this subnet mask, system can able to divide an IP address into network portion and host portion if the and it will find the network ID of that IP address. When both systems are communicating each other, when two systems are communicating each other, if both the network ID is same, both devices network ID is same, so they will communicate each other. It means their network portion is must be same, so they will communicate each other. Otherwise, they can't communicate. Okay. So subnet mask use AND gate logical operations to calculate what is the network portion and host portions finding a network ID. Guys, look at here. The class A, the network portion is first portion and remaining are host portions. So look at this. The default subnet mask is 255.0.0. Class B default subnet mask is 255.255.0.0. Class C, the default subnet mask is 255.255.255.0. Why it is 255.0, guys? And as we said in a class A, the entire first portion is network, remaining are host portions. And the subnet mask once represent binary ones represent network bit and zeros represent host bits. Okay. So this is entirely network portion means its octet contains 8 bits means all are ones only. And host is represent as now host. This is by default. We can able to change it, but one condition is there. Ones are always follows from the left to right. Now middle ones won't come here. Okay. So this is a network portion. This meaning is 255. And this meaning is 0, this meaning is 0, this meaning is also 0. So this is your default subnet mask. Okay. Network represent ones. Network bits representation of ones. Ones represent network bits. 0 represents host bits. So your entire first portion by default is network portion. It means the entire first portion is all are ones. And remaining as host portions means remaining all are zeros only. And you convert it, it's 255.0.0.0. This is our class A subnet mask. It same goes for class B and class C. You see, the first two portions are network portion, remaining two are a host portions. So first two portions contains 8 ones and 8 ones. The equivalent is 255, 255.0.0. And class C, first three portions are network portions. So first portion, second portion, third portion is all are ones only. So it is 255.255.255.0. Beside that one, there is some calculation. I will explain that calculation. Okay, just like that. Guys, understand what are the default gateways of your network, like a based on watch class? What is there? Sorry, I'm mistaken. Sorry. What are the subnet mask, default subnet mask for a different class of IP addresses? Depends upon what IP address you given. If you have to give a default subnet mask based on that class, you have to give the subnet mask. By default, it is. Of course, we can change it. The changing I will explain later. Do you understand up to here? Okay. As I said, guys, our system use subnet mask to define what is the network ID and separate your IP address into network part and host part. So when it is communicating from one system to another system or one device to another device, when it is communicating, it verifies both are in the same network or not. If it is not there, so it won't communicate. If it is there, it may communicate each other. Okay. In the same network, in the same logical network or physical network it is. Okay. How this our system use subnet mask to divide or finding network ID, it is use end operation, end gate operation. Okay. What is this end operation? If there is a input A and there is a input B and the output is Y, A dot B expression. If both our inputs are 0, output is 0. Is only one of the input is 0, output is 0. If any one of the input is 0, output is 0. If both inputs are ones, then output is 1. This is a logical operation. AND gate operation. Okay. And then how it can able to find an IP address of network ID. Here it is. In subnet mask, once represents network bits, 0 represent host bits. 255 means 111, 1111. 0 means 000 000. Okay. Guys, you take a network and you've started writing a network one by one. So we'll start from here. See, it is 192.168.1.0. This is a network, a starting one. This one we call it as a network ID. As I said, if both system network ID is same, they can able to communicate each other. 192.168.1.1. Okay. It is a first valid IP. What is meant by valid IP? You can assign that IP address to any of the adapter. Any system you can assign 192.168.1.1. That is the first valid IP address after network ID. Okay. You have a computers, then you started assigning one by one IP address. First is 1.1, second one is 1.2, other one is 1.3. Okay. Cities keep on going. There is a 116.8.1.250. This is the last valid IP address. Okay. So 169 to dot 168 dot 1.255. See, it is still, from the starting. I started from here and up to here. If you see, the network portion is not changed. Either any of the octet of network portion is not changed. So this is the last one. So this is called a broadcast ID. Okay. This is the network ID and this is the broadcast ID. No, what is the next one? Automatically it is 2.0. So when it is go to the 2.0, it is different network from earlier. It is another network. It is network ID of 2.0 network. Okay. So same network means from starting to ending, the first one is network ID, the very last one is broadcast ID. And in between all these IP addresses, we can assign to the any of the device. And if you are observe, this is a network ID, this is broadcast ID. This network ID and broadcast ID, we cannot assign to any device. In between them, we can assign to any of the device. Okay. So 2 or we are not able to use it. But we started with a 0, ended with the 55. In this case, we started with a 0, ended with the 55. It is around 256 addresses we got it out of 2. Out of that 2 IP addresses, we cannot able to use it. It's a 254. Number of host means computers. We can assign IP address in the class C range. The class C range. If you see, if you see the last part is host part. It is a one octet, one host octet only. 2 to the power of 8. It is 256 minus 2. Why minus 2? We cannot assign host ID and sorry, we cannot assign network ID and broadcast ID. So minus 2, 254 systems we can able to connect. Maximum of 254 systems we can connect in a single network with the help of class C IP address. And coming to the class B, the two host portions, it means 8 zeros plus 8 zeros, 16 zeros. 2 to the power of 16, 65,536 minus 2. Why minus 2? We cannot able to assign two IP address. One is network ID and broadcast ID. Remaining are we can able to assign 65,500 systems. You can able to connect and configure with an IP addresses. Okay, in a single class B network. Same goes for a class A. Last three portions are host portions. It's a 3 8s, 2 to the power of 24 minus 2, and we are getting 16,777 to 214 IP address. Guys, because of this calculation, for example, in my organization, I have a I have a 100 computers are there, and my boss tell so plan for an IP address and suggestion. Which suggestion which you I want pick a class A or class B or class C. Okay, I have only 100 computers are there. I want to connect 100 computers and assign an IP address. For example, which class you prefer, class A or class B or class C? If I use class C, we got 254 IP address minus 100. It is 154 IP addresses we are wasting. We are not using. If you take class B, 65,534 minus 100. Okay, like this. Okay, so many I'm wasting with the class B IP address. Better I use class C because I have 100 computers, wastage is lesser. But if in case you have a 300 computers, then you have to go to class B. 500 computers, go for a class B. 1,000 computers, go for a class C. 5,000 computers, go for a class B. Up to 65,534. In class A, it's not at all. You cross more than 65,000, like a 70,000 people are there, then you can use. Okay. So this is if you take a network, if you start writing from the very first to the last one before changing into the other network. So this is entirely your network. The very first one is mostly your network ID. Very first one is your network ID. Very last one is your broadcast ID. Between the network ID, broadcast ID, we have a valid IP addresses we can able to assign to the client pieces. Okay. So for a class C, it is 254 maximum number of hosts we can able to connect. Class B 65,534. Class C is 16,777,214 IP address. Okay, guys, understand? Class A, Class B ranges, network and host portions, default subnet mask of Class A, Class B, Class C, plus number of hosts for a one network based on what class it is. Do you understand up to here? Okay. So after this one, you are going to check how to find a network ID of an IP address. Okay. So take a small break I'm going to stop the recording. Take a small break, just like a